All right, our final example for finding the intersection of two lines in 3 space. So we have both of them are in algebraic form. Very, very similar to the previous one, and I'll just quickly go through it and just remind you of the process here. So again, you are just breaking it down, and it's easier to write it in parametric form so that you can obtain your 3 equations. The key with the process itself is that nothing really changes in terms of whether it's 2D or 3D. What does change is that you need to make sure you check your third coordinate, all right, to make sure that the values work for it. So again, we compare our x values, and what we end up with is an equation involving the 2 scalar values from the equation. So it's going to look like this, -5. Then I'm going to have y1 equals y2. So -3 minus 4t equals 1 plus 3s. So let's go -4t minus 3s equals 4. I have 2 equations. Those 2 equations that I have then, I'm going to use elimination with in order to find the values of t and s. I'll use those values of t and s to determine if in fact a point exists. So I'm going to multiply, save myself a little bit of time this round, multiply that equation by 3. So I end up with 15t minus 3s equals -15. -4t minus 3s, and that would be a 4. I'm going to do subtraction because the signs are opposite. That allows me to eliminate my s terms. So that means I'm actually adding, end up with 19t equals -19, which means that I have a t value of 1. So I need to use one of my above equations to find s, and I'm going to use the 5t. So if t equals 1, 5t minus s equals -5. The s is already isolated, so it's less work. Equals -5. So moving the s to the other side, I get 10 equals s. So now I have my values of s and t to make the x and y component work here. Remember, you have to do the check. It's not something that is nice to do, it is a must do. So we're going to check our Z1, and the Z1 was 4 plus 2t, and our Z2 is 7s. Filling in the information, get 4 plus 2 is 6, so Z1 is 6. Z2 is going to be 70. Z1 not equal to Z2. So what does that mean? It means that you can find, it is possible to find an XY coordinate that will match up on 2 lines, but because Z1 not equal to Z2, they're not on the same plane, so the lines are skewed. Okay, so that means that on a piece of paper, I could have line 1, and line 2 is above the paper, and they do share an XY coordinate, but they do not share a Z coordinate because they're not on the same piece of paper. So the conclusion there, so there's your visual representation, so therefore the lines are skew. Lines are skew. All right. There's the homework below. Make sure you try enough of them. The biggest fall down on this is people get confused when it comes to the test because they think, oh, it's easy. Once I've seen the examples in the video, there's no sense in practicing, and then test comes around and things get confusing because we're not just doing lines in 2 space, we're also be looking at lines in planes and so on and so forth. So it gets more complicated yet. So you need to make sure you have this down in a comfortable fashion. Good luck. If you have any questions, you know where you can find me.